All right, so now what we need to do is we're going to substitute complex numbers into a polynomial or a rational fraction. And so basically we're going to be given this function and we want to evaluate it at 8 minus I basically. We're going to plug in 8 minus I wherever there's an x. Okay, so what does that give me? Well, f of 8 minus I equals 2 times 8 minus I squared minus 3 times 8 minus I. Okay. Well, I'm going to have to square this, and I'm going to have to distribute here. So I'm going to square first. I'll do that over here. So 8 minus I times 8 minus I. First, 8 times 8, that's 64. Then outer, 8 times a minus I is going to be minus 8I. Inner, minus I times 8 is going to be a minus 8I again. And then a minus times a minus is plus, and it's going to be I squared. So plus I squared. All right. Well, I can simplify this, and I know what this is equal to. And so then I say 64 minus 16I, and then that's going to be minus 1. Remember, I squared is equal to a minus 1. And so when I simplify that, that gives me 64 minus 1 is 63 minus 16I. Now, I also have to take that times 2. So let's go ahead and take that times 2 before we plug it back together on the left. 2 times 63 minus 16I. Well, 2 times 63, that's going to be 6, 12, 126, and then minus 32I. Okay, so all of this took care of this piece here. So now we got 126 minus 32, oops, 32I. Okay, maybe we should erase that. And then let's go ahead and do that over here too. So we have a negative 3 times 8 minus I. So when we distribute here, that's going to be a negative 24, and that's going to be plus 3I. So then we have minus 24 plus 3I. Okay. Now we have to find like terms. Well, constant, constant, imaginary, imaginary. Well, 126 minus 24 is going to be 102 minus 32 plus 3 is going to give me a minus 29I. Now that's in the form A plus BI, and so that would be my final answer, okay? And again, all it took was we had a FOIL, then we had to distribute, and then on here we had to distribute, and then we just added like terms together, and we got our 102 minus the 29I. All right, what about one where we have a rational number? So we're plugging in a negative I for x. So f of a negative I equals negative I plus 1 over negative I minus 4. Now, that's not really in the standard form, so I'm going to rewrite it just so I understand what's going on. We have 1 minus I over a negative 4 minus I, okay? Because remember, I need to find the conjugate of the denominator, multiply numerator and denominator by that conjugate, and then simplify. And so my conjugate is going to be what? Well, it's going to be a negative 4 plus I. Now, if we had it like this, some people have the tendency to say, oh, I just changed this sign to a plus and I have negative I plus 4. But as you can see, it's negative 4 plus I. And so you always want to get it into that form A plus BI before you do any finding of conjugates, because otherwise you might find a conjugate of A, not the imaginary part, okay? So now we're going to multiply by a negative 4 plus I over a negative 4 plus I. Multiply the numerator and denominator by the conjugate. Now we take 1 times negative 4, we get negative 4. 1 times I, we get I. Negative I times negative 4 is going to be plus 4I. And negative I times positive I is going to be a negative I squared. And down here we have a negative 4 times negative 4, that's 16. Then we have negative 4 times, that's going to be a minus 4I. This is going to give us a positive 4I. And this is going to give us a negative I squared, okay? Well, if we look here, those cancel, which, we would expect when we're multiplying by, opposites, because if you take, the A plus B times A minus B, you end up with a squared minus b squared, and the whole middle part falls out. And that's what we just saw. The whole middle part falls out. We have that squared and then minus that squared. So thinking about that, that's what we have. But we still have to add those two together, and we have to convert our I squareds to a -1. So that gives us a -4, and then we have 1i plus 4i, so it's going to be plus 5i. And I squared is -1, so -1 times -1 is plus 1. Here we have 16, and here again, -1 times -1 is plus 1, so we have that. Now we combine those, so -4 plus 1 is a -3 plus 5i all over 17. And again, a plus bi is the form we want, so that's going to be a -3 over 17 plus 5 over 17 times I. Okay, and then that would be our final value in as a complex number. Okay, and all we did was we plugged in -I for both x's, and then we simplified. All right, so the next one here is simplifying powers of I. So maybe we get into a thing and all of a sudden we have this I to the 25th or I to the 15th. What do we do? Well, let's start writing down the first so many and see what we get. So I to the first, well, that's just I, okay? I squared, by definition, we said that was -1, so that looks good. Then I cubed. Well, how can we make I cubed in the form of one of these here? Well, we can say that's I squared times I. Well, I squared is -1, so it's a -1 times I. Well, that just gives us a -I. Okay, now moving on to the next one. I to the fourth is I cubed times I. And again, we're keeping that I in there so we kind of know what's going on. And I cubed was a -I, so we have a -I times a positive I. Well, that's going to give us a negative I squared. Well, I squared is -1, so it's a -1, which is just 1. Okay. Now we can move on. We can go, 5 through 8 here. So I to the fifth is, well, it's just I to the fourth times I. So we're back here. I to the fourth was 1 times I is just I. And then we have I to the sixth. Well, that's I to the fifth times I. Well, that's I times I, which is I squared, which is -1. And then we can come over here and I to the seventh. Well, that's just I to the sixth times I, which is -1 times I. So that's -I. And then, 8, well, that's I to the 7th times I equals, that's a -1, or I should say, times I, which is -I squared, which is a positive 1 again. And so you can see they kind of follow a pattern here, 1, 2, 3, 4, then 5, 6, 7, 8, 1 and 5 are the same, 2 and 6, and 3 and 7, 4 and 8. And so that's kind of what we're going to do to simplify these, okay? So what we need to do is we need to figure out what we can plug in and do here. Now there's not just one way you can do it. You can do it multiple ways. Maybe if we knew this one, maybe we could say, well, let's take the largest one we know and do I to the 8th. Now what's left after that? Well, what's left after that is I to the 7th. Or we could say, well, it's, I to the 4 times I to the 3. I mean, there's a lot of ways we can do this. And that's the same thing as, I to the 4 times I to the 4th times I to the 4th times I to the 3rd, if you want to break the 8 down into the 4s, okay? It all varies on what you want to do. We could have done the one where we took 8 and 7, and when we took 1 and that, so that's another one. We could do I to the 8th times I to the 7th. It just depends on what you remember. Maybe you only remember the first 4, not the first 8, or maybe you've even memorized out to, the first 12 or whatever. But then you kind of have to show what you've done. Well, I to the 8th we know is 1, so that's 1. I to the 7th is a -I, and so that gives us a -I. Now here, I to the 4th was 1 times 1 times 1 times, and I to the 3rd is a -I. Okay, and here again is 1 times -I. So no matter which way you do it, it's always going to come out to be that -I. Okay, now let's break this one down. Again, let's just say that we remember those first 4. let's say we didn't worry about thinking about, I don't want to have to remember 8 of them if I can remember 4 and work everything with 4. Okay, so that's something we can do. And so what is this broken down into? Well, we can say, well, let's do I to the 4th. That's the biggest one in our first list. Well, if we take another I to the 4th, that's 8. And another I to the 4th, that's 12. And another I to the 4th, that's going to be 16. And then we have the 20. And then, oh wait, 1, 2, 3, 4, 5, that's 20. And we have I to the 4th, that's 24. And now we need to get to 25, so I need times I. Okay. And so again, we just use those first 4. We could have done, the 8 and the 8 and so on, but we just did it this way. Now, what is I to the 4th? Well, that's 1 times 1 times 1 times 1 times 1 times 1 times I. And so that gives us all that things is just equal to I, okay? And again, we can use huge numbers here and we can figure these out and just have to kind of start working your way down to them. All right, what about this? Well, it looks like we're subtracting 2 fractions and we have i's in the denominator. And so what am I going to do? Well, what I'm going to do is I'm going to try to simplify this I to the 11th and I to the 21st before I do anything else to get it to something like, one of these things here, either I, -1, or negative I, or 1. So I'm going to try to get it into one of these formats, I to the 1st through the 4th. So let's do that first. I to the 11th and I to the 21st. Okay, so again, if I do I to the 4th, then what do we have left? Well, and then we have another I to the 4th, that's 8. Then we have to have I to the 3rd. Okay, so we have 1 times 1. Now, if you've forgotten already, for a while, you can look back here and say, oh, that was -1. That's right. Yeah. And so it's a negative I. Okay, and so that's just equal to a negative I. Well, what about I to the 21? Well, now we can go I to the 4th times I to the 4th times I to the 4th. That's 3, 4, 5. We know that's 20 times I. Now we have 1 times 1 times 1 times 1 times 1 times I. And that's just I. Okay. Now, what do we do from there? Well, now we can rewrite our original fraction up here as 1 over negative I minus 1 over I. Okay. Now, what's that going to give us? Well, if we think about that, that's really a -1 over I plus a -1 over I. So that's a -2 over I, right? Okay. Well, that needs to be division because we need to get rid of the imaginary parts in the denominator. We always want the imaginary part in the numerator. So what do we have to do to get rid of the I here? Well, we have to multiply by its complex conjugate, which if this is I, the complex conjugate is a negative I, okay? So on the numerator, we have negative times a negative is positive, so we have 2I. The denominator, we have a negative I squared. Well, that's 2I over a negative 1. Well, that's just 1, so that gives us 2I. Okay. Now, if they want it in a complex form, we have to put that 0 plus 2I. And so that would be the full complex form. So you have to be careful and see what they say. And if all else fails, always put it in a complex number form, and then you don't have to worry because those two are the same thing. So they really couldn't count it wrong. And if they did, then I can give you points for it. All right. What about this one? So here, I think what I want to do first is I want to get rid of the numerator as 2 binomials. So I need to FOIL that out. Then after I FOIL that out, then I'm going to simplify as much as possible. And then I can go ahead and divide by that 1 plus 2i. So doing that, I'll take first times first. So it gives me 2. First times last, that's going to be minus 4i. For inner is 3i times that's going to be plus 6i. And that's going to be 3 times -4, so that's going to be -12, and then I squared. And we're still going to say it's over 1 plus 2i. Okay. Now I can combine those terms. I know that that's a -1. So I have 2, And then I have a negative 12 times a negative 1, so that's going to be plus 12. So 2 plus 12 is 14. 6 minus 4 is 2i. And that's all over 1 plus 2i. Okay. So again, we could have wrote out the different steps and said, okay, well, it's 2 plus 2, or it's, 2 plus 2i, and then minus 12 times negative 1. Negative 12 times negative 1 is positive 12. Then 12 plus 2 is, 14. But I kind of have figured that hopefully you're figuring out how to do simplified steps so you don't have to write out 30, 40 steps, and you can see how that works. Okay, so now I've got to the point where I have to actually do something else. I'm going to have to multiply by that complex conjugate. And remember, all we do is we change that sign, so it's going to be 1 minus 2i. And what I do down there, I do up here. All right, so again, 14 times 1 gives me 14. Then 14 times the negative 2, so that's going to give me a negative 28i. Then inner is 2 times 1, so that's going to be plus 2i. And then 2 times negative 2, so it's going to be minus 4i squared over. Now we have 1 times 1 is 1. Now remember, those middle terms are going to cancel. We have a minus 2i plus 2i. So if we need to, we can write them in, but we know that should cancel. And then we have 2 times negative 2, so it's going to be a minus 4i squared. Okay. All right. What do we know? Well, we know that that's a negative 1 and that's a negative 1. So now let's kind of work with that. So these two we can add together. 28, negative 28 plus 2 is going to give me a negative 26i. And then I have 14 minus 4 times a minus 1, so it's going to be plus 4. So 14 plus 4 is going to give me 18. Okay. Now on the bottom, negative 4 times negative 1 is 4, plus 1 is 5. All right. Now again, we have to get it into the form a plus bi, and so we have to break this fraction down into 18 over 5 minus 26 over 5 times our I. Okay, and then that would be our final form for this problem here. And so that's all I have for this section, so hopefully it helped.